Hello again. Welcome to Astronomy Daily with Steve and Hallie. It's the 28th of April 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Well, welcome back to Astronomy Daily. It's great to be here, and with me, as always, is my awesome digital pal who's fun to be with. Hello to you, Hallie.
Hi again, human. Nice to be with you in the Australia studio.
You're very welcome.
What's with all this rain?
Oh yes, our crazy rain.
I thought Australia was a land of sweeping plains and ragged mountain ranges and wide, red deserts.
Oh, well, it is all that.
It's all wet.
Oh, I know, Hallie. I think somebody washed their car.
Oh, that old wives' tale. Was it you?
Who, me?
Did you wash your car?
Oh, it might have been, you know. If you don't mind, I'd prefer not to talk about it on the air. It's been raining pretty hard and people might want somebody to blame and, someone. And I'd like that person to, not be me.
Steve washed his car. Steve washed his car.
Hey, Hallie.
Just kidding. You are so easy. Do you know that?
Yeah, I do know that, but I also have a very clean car.
Funny. Now, are you going to tell us about today's lineup?
Okay, Hallie, if you'll behave. Today's stories include the latest chapter for the Chang'e 5 samples, which are about to go on tour in the United States, visiting some universities.
Sounds good.
Also, the latest news out of Firefly Aerospace. Remember their amazing moon landing recently and that amazing video footage of the lander descending to the lunar surface?
That was spectacular.
Well, Firefly Aerospace are not sitting on their hands.
You're a big fan of Firefly.
Yeah, that's me. And the other tale today is from fireflies to dragonflies, is about the NASA Dragonfly helicopter. That's under development, which is going somewhere special.
That's the one planned for Saturn's moon Titan.
Saturn's moon Titan. Oh, wow. Yeah, it's an amazing piece of engineering so far.
But exploring Titan.
Yeah, that's really out there.
Fantastic.
I know, and you'll be bringing us that story as well, right?
I've got it ready on my drive.
Okay, well, let's get into it, Hallie. Let's hit it.
Okies. China has accepted a number of international applications to borrow small portions of moon samples collected by its Chang'e 5 mission, including those from 2 U.S. universities. The China National Space Administration, CNSA, announced the results of a latest round of international applications to borrow samples in Shanghai, April 24, during a conference marking China's 10th annual Space Day. The event included a lunar sample loan agreement ceremony. 7 universities from 6 countries, the US, Japan, Germany, France, the United Kingdom and Pakistan, had applications approved, following a CNSA review in accordance with its sample management and cooperation rules, CNSA said in a statement. The US institutions are Brown University and Stony Brook University, both of which receive NASA funding. The announcement comes amid US-China trade tensions following the imposition of tariffs by the Trump administration, US barriers to bilateral cooperation on space, and wider Chinese space diplomacy efforts. CNSA also announced the selection of a series of international projects to join its planned Chang'e 8 lunar South Pole landing mission April 24. The selected projects featured countries involved in the International Lunar Research Station, a China-led alternative to the US Artemis lunar framework. The agency also stated in Shanghai that its Tianwen 3 Mars sample return mission, scheduled to launch late 2028, is open to proposals for international payloads. The robotic Chang'e 5 mission collected 1,731 grams of material from a geologically young area of Oceanus Procellarum on the near side of the Moon, using a scoop and a drill, in late 2020. The material was first made available to Chinese researchers and institutions before CNSA announced in August 2023 that international applications for samples would be accepted. NASA stated in November that year that its researchers would, exceptionally, be allowed to apply to loan China's Chang'e 5 samples, while still needing to follow long-standing, congressionally set rules which have sharply limited cooperation between the agency and Chinese state entities. The Wolf Amendment, introduced in 2011, is a provision in annual NASA appropriations bills which heavily restricts bilateral cooperation with entities of the People's Republic of China. Any NASA-funded individual or entity seeking to engage in bilateral activity would require a prior written request to, and granted permission from, Congress in advance, along with certification from the FBI that the activities would not pose a national security risk. Analyses of the Chang'e 5 samples have led to discoveries including the new mineral, Chang'e site-Y, evidence of a prolonged lunar dynamo, and allowed insights through comparison with the geologically older Apollo samples. China followed up the success of Chang'e 5 with a more complex sample mission to the lunar far side in 2024. The Chang'e 6 mission collected 1,935.3 grams of material from Apollo crater, located within the vast South Pole Aitken impact basin, and the first-ever collection of samples from the far side. The material has so far provided insights into the lunar near-far side dichotomy, as well as validation of the lunar magma ocean hypothesis and calibration of lunar crater chronology, helping to refine comparative study of planetary surfaces across the solar system. Chang'e 6 samples are so far only open to applications to Chinese institutions. However, as with the Chang'e 5 samples, these will be made available to international applications at a later date. The landing of Chang'e samples reflects China's broader strategy of using space cooperation to build international partnerships, particularly as competition with the US over lunar exploration intensifies.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X, or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
NASA's pioneering Dragonfly mission has cleared a key hurdle, keeping it on track for a 2028 launch to Saturn's huge moon Titan. Dragonfly is a car-sized, nuclear-powered rotorcraft designed to investigate Titan's potential to host life, and it has passed its critical design review, NASA announced on Thursday, April 24th. Passing this mission milestone means that Dragonfly's mission design, fabrication, integration and test plans are all approved, and the mission can now turn its attention to the construction of the spacecraft itself, NASA reported. The $3.35 billion Dragonfly mission was first selected by NASA in 2019 and is being designed and built under the direction of the Johns Hopkins Applied Physics Laboratory in Maryland, with APL's Elizabeth Turtle as the principal investigator. The mission has been hit by delays and cost overruns, but studying Titan is considered a high priority by scientists for its potential to harbor alien life. The mission is set to launch no earlier than July 2028 on a SpaceX Falcon Heavy rocket from NASA's Kennedy Space Center in Florida. The spacecraft will then embark on an almost 7-year-long voyage through deep space to the Saturn system, with the goal of spending more than 3 years studying areas across Titan's frigid and diverse surface. Equipped with cameras, sensors and samplers, Dragonfly will assess Titan's habitability, looking out for prebiotic chemistry as well as potential signs of life. Titan is Saturn's largest moon, and the second largest in the solar system behind Ganymede of Jupiter. Its thick, hazy atmosphere shrouds a surface featuring dunes of hydrocarbons and methane lakes. Beneath the moon's icy crust, scientists think there's a subsurface ocean of salty water, adding to the possibilities for Titan to harbor life. In 2005, NASA's Cassini mission delivered the Huygens probe to Titan. The European Space Agency built Huygens made a parachute-assisted landing, which provided profound insights into the giant moon. Dragonfly, if successful, could revolutionize our understanding of how life might arise elsewhere in the solar system.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
Firefly Aerospace is preparing its Alpha small satellite launcher for a flight from Vandenberg Space Force Base in California. The Alpha FLT A006 mission, named Message in a Booster, is scheduled to launch on Sunday, April 27 at 6:37 a.m. from Space Launch Complex 2 West at the start of a 52-minute launch window. Message in a Booster will fly on a southern trajectory out of Vandenberg carrying a Lockheed Martin LM-400 satellite bus into polar orbit. With this mission serving as a demonstration flight, Lockheed Martin plans to offer the LM-400 as a multi-mission satellite bus for commercial, civil and military uses. This flight, Firefly's second for Lockheed Martin, is also the first of up to 25 missions in Firefly's multi-launch agreement with Lockheed Martin that was reached in 2024. Powered by 4 Reaver engines, Alpha is capable of flying up to 1,030 kilograms to low Earth orbit or 630 kilos to a 500 kilometer altitude Sun synchronous orbit. Lockheed Martin describes the LM-400 as a mid-sized satellite bus with a volume comparable to that of a home refrigerator and the capability to host a 1,100 kilogram payload. Given this flight's destination in a polar orbit, the LM-400's payload is going to be constrained, although it's likely to be the heaviest payload Alpha has launched to date. The LM-400 multi-mission satellite bus is designed to operate in low Earth orbit, medium Earth orbit and geosynchronous orbit. The bus can be used in either single or multi-satellite launch configurations and will have the ability to be launched on multiple rockets. The LM-400 is designed to support up to 6 satellites with a single launch stack arranged in a configuration similar to Starlink satellites on SpaceX missions. This bus was also designed to support onboard data processing using a Lockheed Martin software-defined satellite architecture that conforms to a modular open systems architecture. This enables interoperability with systems deployed by all United States military services. Lockheed Martin states that the LM-400 can support various mission types including remote sensing, imagery, radar observation and communications, with the demo mission on Alpha featuring a communications payload. The company has also developed an electronically steered array that is compatible with this bus and will be flown on this mission. The LM-400 is designed for mass production in large numbers, and a rapid production line is being implemented at a 266,000 square foot manufacturing facility in Waterton, Colorado near Denver. The bus is being pitched as a solution for satellite constellations, with several contracts already secured, including one from the US Space Force for its MEO missile track custody program. The US Department of Defense is moving toward operating constellations of smaller satellites, a prime example of being Starshield, a military constellation based on SpaceX's Starlink satellites, for resilience and redundancy in the face of potential threats to satellites in orbit. Lockheed Martin is one of the US's primary military contractors, and the LM-400, though capable of supporting civil and commercial missions, was really designed to support military standards. Message in a Booster will serve as Alpha's first launch of 2025. Alpha's next flight, the yet-to-be-named FLTA-007 mission, is currently planned to be the first flight of Firefly's Elytra orbital vehicle. FLTA-007 will also be a responsive space mission, meaning the time between the flight's order and launch will be accelerated to be as short as possible. Alpha launched the Victus Knots responsive space mission in 2023, and Firefly has offered this capability to the DoD for similar flights. Although Alpha has only launched out of SLC-2W at Vandenberg, other launch sites are being developed for the rocket. A launch facility at the Wallops Flight Facility on Wallops Island, Virginia, is currently being developed to host Alpha flights. Flights from Wallops are scheduled to begin in 2026 with NASA's Incus mission. South of Wallops, Space Launch Complex 20 at the Cape Canaveral Space Force Station in Florida is another future launch site for Alpha. A facility is also being prepared in Esrange, Sweden, to support missions for Firefly's European customers. The Esrange facility is also expected to be ready in 2026. Alpha has flown 5 flights so far, with its first flight failing to reach orbit. The 4 other flights have all reached orbit, with 2 full successes and 2 partial successes. The company has encountered issues with restarting its Lightning second stage engine in orbit. Message in a booster will see the Lightning complete only with a single burn during its ascent into orbit. As Alpha continues to fly missions, Firefly is working on its upcoming medium launch vehicle rocket in cooperation with Northrop Grumman, which is working on a new version of the Antares launch vehicle that will utilise the MLV's first stage. Firefly currently has up to 6 missions planned for Alpha in 2025.
And there's another episode in the can. Thanks for joining us today, everyone.
Yes, we covered Changi 5 samples, the Titan-bound Dragonfly helicopter development, and more from Firefly Aerospace.
A colorful episode of Astronomy Daily.
And we know where to get our daily dose of all the news from orbit and beyond, don't we, Hallie?
We sure do. Just check out the websites you mentioned earlier.
And put your email in the slot provided.
You won't miss a thing.
Well said. And now it is that time.
So soon. Oh well.
That's okay, Hallie. I know you'll be heading off to the Astronomy Daily virtual studio with Anna.
Don't forget to catch Anna during the week with all the Astronomy Daily updates.
That's right. All the best from Anna. And that's goodbye from you.
And so long from me.
Cheerio.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.